The principle of conductometric titration is based on the fact that during the titration, one of the ions is replaced by the other, and invariably these two ions differ in the ionic conductivity, with the result that conductivity of the solution varies during the course of titration. The equivalence point may be located graphically by plotting the change in conductance as a function of the volume of titrant added. In order to reduce the influence of errors in the conductometric titration to a minimum, the angle between the two branches of the titration curve should be as small as possible. If the angle is very obtuse, a small error in the conductance data can cause a large deviation. The following approximate rules will be found useful. The smaller the conductivity of the ion which replaces the reacting ion, the more accurate will be the result. Thus it is preferable to titrate a silver salt with lithium chloride rather than with HCl. Generally, cations should be titrated with lithium salts and anions with acetates, as these ions have low conductivity. The larger the conductivity of the anion of the reagent which reacts with the cation to be determined, or vice versa, the more acute is the angle of titration curve. The titration of a slightly ionized salt does not give good results, since the conductivity increases continuously from the commencement. Hence, the salt present in the cell should be virtually completely dissociated. For a similar reason, the added reagent should also be a strong electrolyte. The main advantages to the conductometric titration are its applicability to very dilute and colored solutions and to systems that involve relative incomplete reactions. For example, which neither a potentiometric nor indicator method can be used for the neutralization titration of phenol, Ca equals 10 to 10, a conductometric endpoint can be successfully applied.